Hello and welcome to lesson 7 in our study of mathematical biology 2. I'm Bodo Randolph and I'll be taking you through this lesson. And I would also like to say a very big thank you to my lecturer in mathematical biology 2, Dr. Benedict Barnes, who has been making things very cool for me. So, in this lesson, we'll be talking about Nullcline analysis. Okay, and so far we've been discussing some population models, right? And after deriving the models, we mostly analyze it. So far we've analyzed it qualitatively, analytically, using the phase plane analysis. Okay, and there is also another way that we can do the analysis, and that is called the Nullcline analysis. Okay, right. So that's what we'll be discussing in today's video. It just helps us to get our fixed point quantitatively, and by the end of the video you see how it is done. So in mathematical analysis, Nullclines, sometimes called zero growth isoclines, are encountered in a system of ODEs like this one that we have here. So you see we have a system of ODEs, right? N of them. I hope you can see that here. Right. So when we have the system of ODEs, then the J Nullcline is the geometric shape for which S prime J is equal to 0. Okay. Alright, so this definition is very, very simple to understand. But if you don't understand it yet, don't worry. We are going to illustrate it with an example and the understanding will become clearer. Okay. So the equilibrium points of the system are located where all of the Nullclines intersect. So that means that when you draw all your Nullclines, right, the point of intersection is the fixed point or the equilibrium point or stationary point. Okay, so we are going to consider two-dimensional, right, where we can use graph sheet to plot. So in a two-dimensional linear system, the Nullclines are represented by two lines on a 2D plot. Okay, so when we have just two-dimensional, right, and the system is linear, then our Nullclines are represented by two lines on a 2D plot. So let's take an example here. You know, when you take this model here, this model is a competition model, right? Okay. And when we use these equations, okay, actually this is not part of the Nullcline. I just want us to use the non-dimensionalized equation for the competition model, right? To explain what the Nullcline analysis does. But before that, we know this is the competition model, and when we use these equations to non-dimensionalize it, we are going to get what I've called equation A here. All right, this one. And if you don't know how the non-dimensionalization was done, you can watch lesson 4, right, to help you know how to non-dimensionalize equations. Or you can watch the previous lesson, that's lesson 6. This same thing was done and we showed working for it. Okay, all right. So when you take this system, all right, there's a non-dimensionalized system and you want to perform Nullcline analysis on this system. All right, so you can see that we have two of the equations, right? So to perform the Nullcline analysis on A, the first thing that we do is that we find U1 Nullcline and we also find U2 Nullcline, right? And we plot them, right? Considering different regions if you have parameters. Then where the two lines intersect will be a fixed point. If they don't intersect, that means that within that region, we're not going to have any fixed point there. Okay. So um To find the Nullcline, the U1 Nullcline, what we do is that we put the U1 detail to 0. So you put this to 0, right? And when you put that to 0, it is going to give us U1, all multiplying 1 minus U1 minus A1 U2 equals 0. And this implies that U1 is 0, or 1 minus U1 minus A1 U2 is 0. Okay, so we take this equation here. That's 1 minus U1 minus A1 U2 equals 0. And we decide to make U2 the subject. Okay, alright. So the reason I'm making U2 the subject is that we want to get something which will be of this form: y equals mx plus c. That is the equation of a straight line. So when we make U2 the subject, we will get U2 from here. We get U2 to be equal to 1 over A1 minus 1 over A1 U1, which is the same as this. So you see, when you compare this to the equation of a straight line, you can see that 1 over A1 here corresponds to C. That's the intercept, the y-intercept, and the gradient m here is minus 1 over A1. Okay, alright. So that means that this here is a straight line, right? And you know, most of the time when we want to plot a straight line, we use the intercept to get points to plot it, right? So we are going to do the same thing. Okay, so when we take this our equation here, when we take the u1 intercept, the u1 intercept is the point when u2 is what, 0. So when u2 is 0, from here you are going to prepare everything from here. We get 0 will be equal to 1 over a1 minus 1 over a1 u1, and when you multiply through by a1, you get 0 will be equal to 1 minus u1, and this implies u1 is 0. So that means that when u2 is 0, u1 is 1. This implies that u1 is 1. Okay, so the u1 intercept will give us this point, and we have to also do u2 intercept. So u2 intercept, at u2 intercept, u1 is 0, right? So when we put u1 equals 0 inside that equation, we get u2 will be equal to minus 1 over a1 times 0 plus 1 over a1, which is 1 over a1. So that means that with the u2 intercept, we get a point 0, 1 over a1. So that means that whenever you want to plot this line, right, we are going to use those 2 points. Then now we find the u2 Nullcline, right? We're having two equations, right? So we have done for u1, and we have to also do the same thing for the u2 Nullcline. So to find the u2 Nullcline, we put the u2 the tau to 0, right? And when we do that, we are going to get rho u2, all multiplying 1 minus u2 minus a2 u1 equals 0. And from here, we can see that rho u2 is equal to 0. And what this implies is that either rho is equal to 0 or u2 equals 0. But we know that if rho is 0, then everything here is going to be 0. So this implies that u2 is what? 0. Okay. So u2 is 0, or whatever we have here is also what? 0. Okay. So when we take this, as I said, we want it to look like this. That's the equation of a straight line. So 1 minus u2 minus a2 u1 equals 0. When you make u2 the subject, then we get u2 be equal to 1 minus a2 u1. So to plot these straight lines, we will need points, right? And in order to find a point, you are going to consider the u1 intercept and the u2 intercept, just like we did in the case of u1 Nullcline, right? So with the u1 intercept, u2 is 0. So when you put u2 equals 0 in this equation, you get 0 will be equal to 1 minus a2 u1, and which implies that u1 is what? 1 over what? a2. So that means that we have this point. Then with the u2 intercept, it means u1 is 0. So when you put u1 equals 0 inside that equation, you get u2 will be equal to 1 minus a2 times 0. And you get u2 to be 1. So that gives us the point 0, 1. So that means that now we have the 2 points to plot the first line and the 2 points to plot the second line. I hope you get it. And so To plot this line, we use these 2 points, and to plot this line too, we use these 2 points. So now we're coming to do the Nullcline analysis. Okay, but one thing I should notice is that our A1 here and A2 here are positive parameters, right? So they are positive parameters means that they can range from 0.001 going, right, but they are not negative, right? And they are also not zero, because if they are zero, then this thing will be undefined, right? So A1 and A2 are positive parameters. Okay, so yeah, note that. So to plot the lines, right, to plot these points, because A1 and A2 are parameters, they can take a range of what values. So that means I will have to consider some regions when A1 is this, when A1 is that, what we can have. Okay, and that is what the Nullcline analysis is about, and that's what we are coming to do. Okay, so you can see that we have, for instance, with the first line, right, when you take the first line, we have A1, we have A2. So there can be a case when our A1 will be greater than 1, A2 will be greater than 1, right? That will give us one region. We can also have a case when A2 is greater than 1, but A1 is less than 1. We can have a case when A2 is rather less than 1 and A1 is greater than 1. And you can have a case when all of them are less than 1, alright? So that means we can have 4 different cases. We will have to consider 4 different cases in what? Plotting these points. Okay, that's what we are going to do. So case 1, we are going to consider when A2 is greater than 1 and when A1 is greater than 1. Okay, alright. So you see, with the first line, to plot the first line, the simplest point is what? 1 0, right? So 1 0. So this is our U1 Nullcline, U2 Nullcline. So 1 0 will be here, right? Then we have to plot 0 1 over A1. But since we are saying A1 is greater than 1, that means that we have 1 over, for instance, any number greater than 1, we can have 2. And this thing is always less than 1. So that means that that point is going to fall below what? 1. So we can have it somewhere here. That is the point. So this is the point 0 1 0. And this is the point 0 1 over A1. I hope you get it. Right? Since A1 is greater than 1, that means we'll get something which is less than 1. So it will be below 1. Then we can join this line. So this is the line U2 equals minus 1 over A1 U1 plus 1 over A1. Right? So we have to plot the second equation or line here, right? So that one is U2 equals 1 minus A2 U1, right? And now on the point that we have is 0 1 1 over A2 0. So this will be 0 1. It's very easy to locate it, right? 0 1. But now we have to plot 1 over A2 0. But we are saying, we are considering a case when A2 is greater than 1. So that means that 1 over A2 will be less than 1, right? So 1 over A2 can be somewhere here. So this will be 1 over A2 0. And that will also give us this line when we plot it. Okay. So you could see that they are intercepting, right? And the point of intersection is the fixed point. Do you get it? So the fixed point is where the two Nullclines meet. That's when the U1 Nullcline meets the U2 Nullcline, right? So that means that, this is not drawn to scale, but this here is a fixed point. Okay. And to discuss the stability of this fixed point, what we do is that numerically, what we do is that, this fixed point is a stationary point. Okay. So we take any two unstationary or non-stationary points. Okay. So this is our fixed point, and we take any two non-stationary points and we plot them inside the equations that we had. Right, this equation. So we take those 2 points and we put them inside the two equations, right? So if they give us a negative value, right, then that means that they are moving, they are stationary, right? That means that they are stable, so asymptotically stable, so they are moving towards this point, the stationary point. And if those 2 points that we pick, like those non-stationary points that we pick, if they are positive, if you put them inside the equation and they are positive, it means they are what, unstable. Okay, so when you draw your Nullcline, right, you'd be able to, if there is an intersection which indicates that there is a fixed point, you'd also be able to use this to know whether the fixed point is stable or unstable. Okay. All right. So we can also consider the case when a2 is greater than 1 and a1 is less than 1. Okay. So when we take the first line, where is it? So the first, or the u1 Nullcline, right? These are points that we are using to plot that one. So 1 0 and 0 1 over a1. Okay. So this is 1 0. Right? And we have 0 1 over a1. But we are saying a1 is less than 1. So you see, that means a1 can be something like 1 over 0.5. And this will give you like 2, which is greater than 1, right? So that means that the point 0 1 over the point 0 1 over a1 will be somewhere here, because it will be on top of what 1 is greater than 1. So we can have that point here. So we can have 0 1 over a1, and that gives us the line for the u1 Nullcline, right? Mhm. Then the point for plotting the second one is 0 1 and 1 over e2 0. So this is 0 1 and 1 over e2. We are saying that e2 is greater than 1, so that means that 1 over e2 will still be something here, because 1 over e2 is greater than 1. We can take like 5. 1 over 5 will be always less than what, 1. So it will be somewhere here, right? And this will give us a point 1 over e2 0. So this is the first line. Okay, we name it. Okay, so when you plot this one, so you are going to get this. So can you realize that in this region, the two Nullclines, they do not intercept? So that means that in this region, we don't have any fixed point. Okay, there is no fixed point in this region. So let's continue, and after that I'll tell you something, then bring the video to an end, the lesson to an end. Okay. Alright, so here a2 is rather less than 1 and a1 is greater than 1. So note that the points for the first Nullcline is 1 0, 0 1 over a1, and the other one is 0 1, 1 over a2 0. So this is 1 0, right? Then we have the point 0 1 over a1, but I think a1 is greater than what? A1 is greater than 1. So A1 is greater than 1 means that you can take something like 2, and this will be less than 1, right? So that point will be somewhere here. So this will be the point 0, 1 over A1. Okay, then we can plot this. Okay, then we are considering the case when A2 is less than 1. So this is a point 0, 1. And if A2 is less than 1, then you can take something like 0, 1 over 0 0.2. And this is always greater than 1. So that means the point 1 over A2, 0 can be somewhere here. And when you plot this, you also realize that in this region too, we don't have any fixed point because the two Nullclines, they do not intersect. Right? They do not intersect. Like there is no intersection. Then let's go to case 4. So case 4 is when all of them are less than 1, right? So this is going to be 1, 0, and the other point is 0, 1 over E1. But since E1 is less than 1, it means that 1 over E1 will be greater than 1. So we have that on top here. So 0, 1 over E1. Then this is 0, 1. And since A2 is also less than 1, it means 1 over A2 will be greater than 1. So you can have that one here. That's 1 over A2, 0. Okay, so when we plot these, you know, this is the first Nullcline that we had. And this is the second one. Right. So you can see that with this one too, there is a point of what? Intersection. So that means that we have a fixed point in this region. And to discuss the stability of the fixed point, this is a stationary point. You take any two unstationary points for u1 and u2, and you choose any value for your parameter, and you put it inside the system that we had, right? So if it is giving a negative value, that means that those non-stationary points are moving towards the stationary point. So the stationary point is stable, asymptotically stable. But if they move away, if they give you a positive value, that means that they are moving away and they are unstable. Okay, so yeah, this is all what we can tell you about Nullcline analysis. Okay, so you could see that when we were doing our analysis, all right, the thing I wanted to tell you, when we were doing our analysis, right, when we had the equation, all of them we had, see from here, we had u1 to be 0, and here too we had u2 to be 0, right, when we're doing this. Okay, so u1 being 0 and u2 being 0 is a fixed point. So that's the reason why in all the regions, when we drew them, we realized that u1 and u2 were meeting. So this is a point 0, 0, and that was a fixed point. Okay, so in all of them, so that was how we get our 0, 0 fixed points. Okay, fine. So thank you very much, and see you in the next lesson. So in the next lesson, which happens to be lesson 8, we'll talk about conservative system. Okay, conservative system. So thank you very much, and see you in the next lesson.